Hello, everyone, and welcome back to Brainwaves. This morning, I welcome back Dr. Vikaas Sohal of UCSF. Dr. Sohal is a Stagnant Family IMRO Assistant Professor of Psychiatry, and his fascination for what he does translates into discovery after groundbreaking discovery. This morning, I welcome him back, and we're going to talk a little bit about um, we're going to talk a little bit more about what we talked about last time he was on Brainwaves, about his discoveries in how brain circuit malfunctions can translate into schizophrenia symptoms, and a few new areas of discovery that he's made. Vikas, thanks for being on Brainwaves again.
Thank you. Thanks, Brandon. I'm glad to be here. I really enjoyed this last time, and I'm looking forward to doing it again.
Okay, well, good. Um, so, um, So you've found something really interesting in your last year of research, and then you've actually observed these regular recognizable patterns of activity in the prefrontal cortex that seem to represent maybe substrates of the way we think and remember and perceive and learn, like cognition.
Yeah.
Is that accurate? And what are these patterns of activity that you've seen?
Yeah. Well, what we really want to understand, obviously, is what goes wrong with brain cells that gives rise to brain disorders. And in order to do that, we have to understand how brain cells normally generate behavior. And what we know is that the prefrontal cortex, which is a part of the brain that's involved in schizophrenia, mediates a lot of complicated behaviors like remembering things for short periods of time or remembering the rules of a task or being able to change your behavior or make decisions. And we think that all of those behaviors are mediated by patterns of activity in brain cells in the prefrontal cortex. And what we think is that sometimes the prefrontal cortex maintains a pattern of activity that's stable over time. So like if you hear a phone number, then brain cells will become active in the prefrontal cortex, and they'll remain active as long as you're remembering that phone number. And then later on, that phone number will be stored in your brain, and you can use it to actually dial the phone. The same way, if you're playing a game, the rules of the game sort of remain represented in a group of neurons that are active in the prefrontal cortex. And so we wanted to be able to really find a way to see these patterns of activity so we could study them. And what we found was that isolated pieces of the prefrontal cortex generate patterns of activity. These patterns of activity are not random, so they are in fact the kinds of patterns that are thought to underlie these complex behaviors.
Wow. Okay. So that could be something big that you've seen. And to diverge slightly, we'll come back to this in a minute. This year, you've also done some more research on how dopamine malfunctions, the dopamine system might give rise to schizophrenia symptoms. And first of all, why does your lab focus on dopamine to understand schizophrenia?
Yeah, so I think that dopamine is obviously one of the things that people have been studying for a very, very long time in the context of schizophrenia. And that's because we know that all of our antipsychotic drugs that we currently use block dopamine receptors, and we know that drugs which activate dopamine receptors, either directly or indirectly, can mimic or worsen some of the symptoms of schizophrenia. So for many decades, people have been interested in dopamine's role in schizophrenia, but what we've realized is there's no simple explanation for how dopamine is involved in schizophrenia. There's no simple thing like, oh, there's too much dopamine in the prefrontal cortex or too little dopamine somewhere else that explains schizophrenia. And so I think because of that, people have gotten frustrated and have gone to look at the role of other brain neurotransmitters, and other brain factors in diseases like schizophrenia, which I think is vitally important. Clearly, there's no one factor which totally explains schizophrenia. But I think we shouldn't throw the baby out with the bathwater. So just because there's no simple explanation for how dopamine is involved doesn't mean dopamine isn't involved. It just means that explanation is likely to be more complicated. And in particular, like I said, maybe we can't understand what dopamine is doing just by looking at, whether there's too much or too little dopamine in one part of the brain. Maybe we need to understand how dopamine regulates circuits and regulates their function, and how that way in which dopamine regulates circuit function is disrupted in schizophrenia. And so that's why we have wanted to do things like measure these patterns of activity in circuits in the prefrontal cortex, because then we can study how dopamine modulates those patterns and modulates the way the circuits work, and how that might be disrupted in schizophrenia. So that's really the direction that we're trying to go in terms of why we're focused on dopamine and why we're trying to study dopamine using these ideas about circuits and behavior.
Okay, that makes a lot of sense. So, um, Well, this year you made some advances in that direction. Like you discovered that a specific type of neuron in the prefrontal cortex, when it's activated by D2 dopamine receptors, uh, gets its electrical activity gets more spiky, and then also you've seen a similar phenomenon, which I believe I understand is a result of that, which is that these patterns of activity we were just talking about, these stereotype patterns, get more prevalent. They happen more often in the prefrontal cortex when the T2 dopamine receptors get activated a lot. Do I have that right? And if so, what does that tell us about symptoms of schizophrenia and how they arise?
That's right. That's absolutely right, Brandon. So what we're trying to understand is how does dopamine regulate the function of the prefrontal cortex? And so we're starting by trying to say, hey, dopamine probably doesn't act the same on every single cell in the prefrontal cortex. And what we've been able to find out is that there are specific cells in the prefrontal cortex that respond to dopamine via D2 dopamine receptors, which are the receptors that are blocked by antipsychotics. And that's important for a couple of reasons. It's important because, first of all, now we know maybe we should really focus on those cells. And it's also important because we can study how those particular cells respond to activation of their dopamine receptors. And when their receptors are activated, those cells do become more active. Their activity outlasts a brief period of input. So you can kind of give the cells some input, and instead of just becoming active and then going back to being inactive, they'll remain active for a long time. And this increased activity is important for a couple of reasons. First of all, we know that it's mediated by L-type calcium channels, which genetic studies have strongly implicated in schizophrenia. So that gives us a clue that maybe this is something that has to do with schizophrenia. But more importantly, it turns out that when these cells become more active, they help activity to spread through the prefrontal cortex. So just as I was telling you before, we see these spontaneous patterns of activity, we see many more of those patterns of activity when these dopamine receptors are activated. Now, why is that potentially important? Well, these patterns of activity are thought to represent something stored in memory or represent a particular idea or a particular behavior. So you could imagine that there are times, obviously, when you want to change what you're doing and you want to have new patterns of activity to represent the new thing you're going to do. So if you're playing a hand of poker and the rules switch from Texas Hold'em to five-card draw, you need to have a new pattern of activity in your prefrontal cortex that represents those new rules. But you can imagine that if you had too many new patterns of activity, if they just started changing inappropriately or all the time, that could lead to disorganized behavior, sort of like what is sometimes seen in schizophrenia or when individuals are psychotic. So that's why we think it's so important to try to really unravel these complex effects that dopamine is having in the prefrontal cortex. And this is the strategy we're taking. We're first identifying where, in terms of which cells dopamine acts on, then we're trying to understand what it does to those cells, then we're trying to understand how that changes the function of the prefrontal cortex by studying things like these patterns of activity.
Okay, wow. It sounds like you have a very good paradigm that might yield some very good, you know, results for understanding the nature of schizophrenia and how it arises and how to treat it. So
Yeah, I
that's
hope
great.
so.
Yeah, yeah. So on that note, I understand that you just had a grant funded, a large grant by the NIMH.
Yes.
Congratulations.
Thank you. Thank you.
Yeah, to continue this research and expand it. So that's very exciting,
Yeah.
and we at MRO we all congratulate you on that.
Thanks.
Definitely. So this is especially noteworthy given that the NIMH has had to recently reduce its budget due to the federal sequester by about 5%, which is significant. And I know a lot of grants have, many grants don't have the opportunity to get funded like yours fortunately has been. So, but all brain research is brain research in general is very important to do because, well, actually, I can ask you about that. Why is brain research so important right now?
Yeah. Well, obviously we're incredibly grateful, for this funding and excited about the work it's going to enable us to do. And, brain research is really exciting and important right now for a few reasons. The first is right now we have a great opportunity. We've finished the Human Genome Project, and now we're trying to study which genes are involved in psychiatric disorders so we can really take all this genetic information and finally start to unravel some of the questions that have bedeviled us for many years. So it's just, we have a good opportunity right now. The second thing is that obviously brain diseases are in the news a lot, and they're in the news for some good reasons. Namely that there's reduced stigma. People are talking about these disorders, and so we can finally start to have a conversation about how to improve our treatments. But they're also in the news because obviously they represent big issues for our society. We have a lot of veterans coming back from Iraq and Afghanistan who are dealing with brain diseases. We've been hearing a lot about gun violence and its possible relationship to brain diseases. And so, the fact that people are talking about these so much also represents, how important they are for our society to tackle right now. And of course, I think it's always a good time to think about brain diseases. They really get to the heart of who we are as human beings, how we feel and how we relate to the world and to other people. And so, of course, we'd want to understand them and do our best to help everybody function as best they can. And then, lastly, they just represent an incredible scientific challenge. We hear about, all kinds of things, the Higgs boson or, other planets, being discovered around other stars. And this is an equally, if not more, satisfying and exciting scientific challenge because, the brain is so complex and we're finally having the tools to study it. And it's really just fascinating. So I think it's really important and an opportune and good time to really focus on brain research right now.
Well said. Thank you for explaining that. And so in order to improve federal funding for research, there are certain things that viewers can do. If you're watching, you may want to check out a website called saveresearch.org, which is run by Research America, and it talks about ways that you can talk to your congressmen and such about advocating for more research funding for research. So that's one thing you can do. Vikaas, do you have any other ideas of ways people can engage in improving funding for research and such?
Well, absolutely. Obviously, I and all the people I work with are incredibly grateful for the donations that we've received, from private foundations that have made it possible for us to do this kind of research. We've received tremendous funding from your family and IMRO. We've received funding from the Simons Foundation, from the Brain and Behavior Foundation, and from the Alfred P. Sloan Foundation. So all of those private donations are really critical to helping getting our research off the ground to where we get federal grants. But we also really benefit from having interaction with the public. When people ask scientists questions, it really is a two-way beneficial street. It gets us to focus on what the really important questions are. It lets us know that people are excited about what we're doing, and that's great. That's what keeps us working. And then, like you said, the last thing is obviously, there's a lot of talk in Congress right now about, oh yeah, we need to do better on the mental health side. But that talk really, unfortunately, has to be followed up by money, and so people can contact their congresspeople and really encourage them to support research.
Okay, thank you for that vote of confidence there. Yeah, definitely, and that suggestion. So, because if viewers want to talk to you about your research, they have a couple of options. First of all, you're coming to the Music Festival for Mental Health, which we are doing on September 7th this year, and
Yeah,
looking
I
forward to
can't
seeing.
wait.
Oh, good. Yeah, definitely. Yeah, looking forward to seeing you there again. So, viewers, you can meet in there if you want to come. You can register at music-festival.org. And if you can't wait to speak to him before then, Vikaas, are you ready to answer some questions after I post this video on brainwaves?
Absolutely, yeah. It's always a great opportunity for me to hear what kind of questions people have and what they're thinking about.
Okay, thanks, Vikaas, so much, and I'll look forward to speaking with you soon.
Okay, thank you, Brandon. I really enjoyed this.
Good. Take care.